Okay, so now that we have learned how to solve equations, we're going to look at solving inequalities. Inequalities are a little bit different. And actually, there's this really cool graphic organizer that we're going to use to kind of figure it out. So step one is to isolate the absolute value. Once we do that, we're going to have and or solutions. So and solutions connect, or solutions are going to go in opposite directions. So if you have an and solution, this means that you have something that you have where the inequality is eating the number, like here. So we have x plus a is less than b, or x plus a is less than or equal to b. Or solutions, notice that the inequality points the opposite way. So if I had a highlighter, I would highlight these guys because this is important, okay? Once you have an and solution, we actually solve them differently. We're going to solve them using like the sandwich method. So we're going to put what's inside in between a negative and a positive solution. Whereas if it's an or inequality, we're going to say x plus a is bigger than b, and x plus a is less than negative b. So we still have the positive and negative, but with the positive and negative, the inequalities are pointing in opposite directions. And finally, we're going to graph them. So and graphs connect, like here. They could be open circles or they could be closed circles. Whereas or graphs, the arrows point in opposite directions, which you can kind of see there. Okay? So we're just going to do two examples today. Starting with the first one, I'm going to push this up so it's not like, sorry, I know the angle's weird. Sometimes things are great, sometimes they're not. Today is not a great one. Yeah, it's kind of slanted, isn't it? Anyways, I'm going to stop messing with it. We're going to start solving and graphing on a number line. So this first example, we have x plus 4 minus 10 is less than or equal to negative 2. So just like when we're solving inequalities, or equations, we're going to start by getting the bars by themselves. So I'm going to start by adding 10 to both sides. Doing this gives me that the absolute value of x plus 4 is less than or equal to 8. Okay? Now, this is where I'm going to pay attention to this inequality. So notice that it matches the and graph, right? It looks like this one. So I'm going to decide that it's an and graph, which means I'm writing it like this. I'm going to say negative 8 is less than or equal to x plus 8 is less than or equal to 8. Just like what I have here. So let's set that up. Negative 8 is less than or equal to x plus 4 is less than or equal to positive 8. So this is because, again, it is an and graph. Okay, so now these they look like they're hard, but they're actually not that hard to solve. So I'm just going to pretend like this is x plus 4 is less than or equal to 8. And this is a one-step equation. We know how to solve this. To solve for x, right, we have to subtract 4. Now, the only thing is because I have a number at the beginning and at the end, I have to subtract 4 from everything. So now, negative 8 minus 4 is negative 12. And 8 minus 4 is 4. Now, there's nothing left to take away from x, so this is actually my inequality solution. Next, we have to graph it. Graphing it, I'm going to put 2 dots, one at negative 12 and one at negative 4. Or sorry, positive 4. So a dot there and a dot there. Now, because this is an and graph, the dots are going to connect. Again, they're closed circles because my inequality has a line underneath it. So to finish this off, I'm just going to connect from negative 8 to positive 4. And that's your solution. So again, and graphs must connect, or graphs are going to be disconnected, which if you know how I teach, this next one's probably going to be an or graph. So let's go ahead and take a look at it. I have negative 2 is absolute value of x plus 1 is bigger than or equal to negative 6. So here, I am going to start by dividing both sides by negative 2. So dividing both sides by negative 2. I'm going to get that the absolute value of x plus 1 is 3. Now, because I divided by a negative, I'm actually going to turn that inequality around. Okay, so let's make a note. dividing by a negative flips the inequality. This should be familiar from integrated 1 when you're working with just regular inequalities, right? It was the same thing. When you divide by a negative, it flips the inequality. Now, I said it was going to be an OR graph because it looks like an OR graph, right? But because I divided by a negative and I flipped that inequality, we have another AND graph. Okay, which means I'm going to set this up as -3 is less than or equal to x plus 1 is less than or equal to +3. Again, the negative and the positive solution. This is good because this is probably the weird thing to you. So now we get to actually practice solving another AND graph. So how do I solve for x? I'm going to start by subtracting 1 from both sides. Actually, all sides. That's going to cancel in the center. -3 minus 1 is -4. And I'm going to have x. 3 minus 1 is 2. So my inequality is -4 is less than or equal to x is less than or equal to 2. I'm going to put a closed dot at -4 and a closed dot at 2. And again, because this is an AND graph, they are going to connect in the center. Trying to make these dots bigger so it doesn't look weird. All right, and that is our solution.